Good afternoon, friends. Good afternoon. Once more, welcome to Paulstutorialservices.com. This is Thursday, the 14th August. Thursday, the 14th August 2025. We are here back at Paulstutorialservices.com. Happy to be back with you guys. Happy to be back with you guys. And as always, we want to look at science. Welcome to Science Odyssey class. Science Odyssey class. And today we want to look at the acidic and pH levels on various substances. Acidic and pH levels on various substances. So we are going to look at the strength of the acidic level, the strength of the acid in various substances, the strength of acid in various substances, and also how strong is the pH levels in different bases. How strong is the pH levels? What's the base of the pH levels in different circumstances? So we are going to look from 0 to neutral and also to strong bases. So we are going to look at the strength of the acid from 0 to neutral, and also to the greatest strong basis, the strongest basis of the acid and the pH level. But before we jump into that, please remember to share today's tutorial. It's very important that we share today's tutorial to your friends, and on your Facebook, on your social media platforms, to your friends, and on your social media platforms. Please remember to share, because we need more people to tune in. We need more people to tune in at Paulstutorialservices.com, where we make learning fun and enjoyable. Tune in every now and then for Paulstutorialservices.com, so that you may learn something. Remember, we are in the digital age, and we are in the social media age, and we want to make good use of the social media. We want to make good use of the mediums that we have, so that we benefit on the digital media. This is the digital age. We are on the digital age, and we have to make the best of it. Follow me always at Paulstutorialservices.com, and we are also on Instagram. I call it ING, Instagram. Follow me there at Paulstutorialservices.com, and follow me at my Facebook page, Paulstutorialservices.com, and visit my website, Pauls101tutorialservices.com, where you can also register for individual one-on-one tuition. You can also register for individual one-on-one tuition at Pauls101tutorialservices.com, where we make learning fun and enjoyable. Remember, when you're there, scroll all the way down to the bottom page. While you're there, scroll all the way down to the bottom page, and click on the contact form. Click on the submission form. And complete that form and send it to me. And we'll be able to send you a link for tuition. Upon your registration and upon your registration and enrollment for tuition class. All these at Pauls101tutorialservices.com. Remember to support this page, this service in any way you can, gift or otherwise. Support this page, this service in any way you can, gift or otherwise. Follow follow my page at Paulstutorialservices.com on Facebook. Follow my page, become a follower of this page, and enroll, subscribe on my YouTube page. Subscribe. I can't emphasize enough. We need subscribers. We need subscribers. Support my YouTube page. Support my YouTube channels, because one time you're gonna need somebody to support your channel. So support my channel. One time you're gonna need somebody to support your channel. Support my page, because there's gonna come a time you're gonna need somebody to support your services, to support your page, and God will bless you. Support my page, and God will bless you. Enroll, subscribe on my YouTube page, subscribe on my YouTube channel. Please subscribe on my YouTube channel, and God will bless you. Subscribe. You can find me there using the handle at Paulstutorialservices.com, using the handle at Paulstutorialservices.com, YouTube channel. Support my services, and God will bless you. Support my services, and God will bless you. So now, without wasting much of your time, and Science Odyssey class, the topic is basic acidic and pH levels. Basic acidic and pH levels. So now when you look at this diagram right here, it's a straight line. And this one you can see I've labeled it from strong. You find that when we are measuring the strength of an acid, we are measuring the strength of an acid on the water. The strength of acid in water. The strength of acid in water, and you can see is the measurements of how to measure the strength of acid. Acid is measured on pH levels. Acid is being measured. For you to measure the strength of an acid, it is measured. The acidic levels are measured in pH levels. The acidic levels are measured in pH levels, and hence you can see it's ranging from 0, and the greatest is 14. The strongest base of acid is 14. The strongest base of the acid or alkaline level is 14. Alkaline level is 14. So now when we talk of acid, you're gonna hear terms like alkalinity level or alkaline level, and you're gonna hear terms like pH values, and you're gonna hear terms like acidic levels or acidic pH levels. All these are under science. So this is science class, and we are discussing about acidity and the pH levels. And as I said earlier, you can see that the measurements of the range of acidity ranges from 0 to 14. 0 being the lowest acid, and the highest level is 14. The highest level is 14. So now, when the pH or acidic level is that strong at 14, so that is dangerous for you. When it is that strong, 14 acidic level or 14 pH level is dangerous. Those are dangerous levels. And you can see the pH level for bleach. The pH level for bleach is 13. The pH level for bleach is 13. So when the pH level is 13, that is a dangerous chemical. You want to make sure you keep it away from kids, and also you keep it away from yourself, and make sure you handle it with care. You handle it with care. When you're using bleach, maybe for washing, make sure you don't swallow the bleach. You make sure you don't swallow the bleach, because that is a dangerous chemical that is hazardous. It's hazardous chemical. Is the pH level for bleach is 13. The pH level for bleach is 13. So you can see pH level for bleach is 13. So now, when it comes to pure water, the pure water, the recommended pH level for water, the recommended pH level for water should not be more than 7. Should not be more than 7. So now the greatest should be up to 7. The greatest should be up to 7. The basic pH level for water should be up to 7. So anything going beyond 7, you want to be careful with that. Anything going beyond the pH level of 7 in pure water, you want to be cautious with that. You want to be cautious with that. So make sure your water is pure, and make sure its pH level is not greater than 7. Make sure its pH level is not greater than 7, and that means it is beyond. If it is beyond 7, then it is acidic. It is acidic, and it's not good for consumption. When it is beyond 7, then that means it is acidic, and it is not good for consumption. So now, if it is so the neutral pH should be 7. The neutral pH level, you can see I've indicated in this diagram the neutral pH. This middle center is the neutral pH level, and it is up to 7. It is up to 7. It is up to 7. Yes, it is up to 7. So the neutral pH level should be 7. The neutral pH level is 7. So now, when it is acidic, also when it is acidic, it should be less than 7. When it is acidic, it should be less than 7. So now, for it to be considered acidic, it should be less than 7. So now neutral is 7. So if it is going below 7, then it is acidic. So when it comes to water, the neutral level should be up to 7. But then now, when it is below 7, then it is considered acidic. So now you want always to boil your water to a pH level of 7. pH level of 7. You want to make sure your water is purified up to the level of 7 pH value. Up to the level of 7 pH value. But if it is below 7 pH value, then it will be considered acidic. It will be considered acidic. So now you can see that when it is up to 0, so that is really strong acid. When it is up to 0, when your water is up to 0 in terms of pH value, then that means it is really it's too strong in acid. It is really too strong in acid. You can see now strong acid as a pH value of 0. Strong acid as a pH value of 0. Whereas, so this diagram literally shows that when the pH value is 7 and above, when the pH value is basically beyond 7, you can see now when the basic pH value is beyond 7, it has a strong base of acidic. It has a strong base of of the pH value. So now pH value and acidic is the topic now, and we have seen how strong it is, it ranges from 0 to 14. So when you look at the alkaline level now, pH, normally pH values measure something called alkalinity. So now the alkalinity level is measured in terms of how strong the base is. So now, if you look at the alkalinity level or the acidity level of the bleach is greater than, is up to 14, is up to 13. But you see now, this line runs, the stronger base would be 14. So bleach has up to 13 pH level for it to be considered a bleach, and now water has a basic pH level greater than 7. Water has a basic pH level greater than 7. So now, it should either be greater than 7, but if it is beyond that, you see, the limit should be up to 7. That's what they mean. The limit should be up to 7 for water to be considered good for us to consume. Pure water should be up to 7. You see here it says pure water. That means it is pure and undiluted. Water that is pure or undiluted should be up to 7 pH value, should be up to 7 pH value. I hope you are following. I hope you are learning something. I hope you are together up to that point. Please continue sharing this video, continue sharing this tutorial. Give me feedback of what you think. Comment something, interact with my content. Comment something, interact with my content. This is live stream, so interact with my content, so that I know what you think. Add some more information that you may have. Add some more information that you may have. As you know, this is learning, and we are learning together, and we're making sure we know some of these things. We're making sure that we are informed and knowledgeable. We're making sure that we are informed and knowledgeable. So if you're a student, I hope you have a pen and paper handy. You can take some notes and compare with what your teacher is also teaching, and so get the right points together. Right here at Paulstutorialservices.com. You can get more of this at my website when you enroll for tuition at my website. When you enroll for tuition one-on-one. So now let me clear this whiteboard. So we do some reactions, so that we do some chemical reactions. We see how chemicals react. We see how metabolism takes place. We see how other reactions of different chemical elements take place. How other different chemical elements take place right here at Paulstutorialservices.com. Paulstutorialservices.com, where we make learning fun and enjoyable, where we make learning fun and enjoyable. So let me write some chemical reaction here, and we're going to solve it together. We're going to interpret it together. So now what I have for us is we have 2CH, we have 2CH. So these two as a number of 2, that is carbon, as a as a number of 2, as an element number of 2 electrons. And then now this hydrogen here has 6. So now there's an oxygen somewhere. So now whenever you see hydrogen, it goes with oxygen right here. And then now, so now we have 2CH6 plus oxygen. So now we want to balance it. So now we want to balance it. So now when we do that, we can see that we have 2 times 2 that will give us 4. We have 2 times 2 that give us 4. So now we're going to have, 4 here. And then there's a C right there. So now we're going to have 4, and then there's a C. And then now, because there's a C here, and you can see 2 times 2 give us 4, then we write this C. And now this C, we're going to add the oxygen. With that C, we're going to add the oxygen, which is O2 right here. So we're going to add the oxygen, which is O2. Looks like I've taken so much space on my board. I've taken too much space on my board. So now let me conserve some space right here. So now 2 times 2 will give us 4, and then we put that C right there. Okay? And then now that C we add that C plus O2, so that's C plus oxygen. So we have 4 carbon dioxide plus 6. We have 6. You can see we have 6 right here. We have that 6. So it's 6 times 0, or 6 times 1. 6 times 1 because there's 1 H. So 6 times 1 is, so we have 6, and then, so we're going to put H, this H, so now we have 6 H, right? We have 6 H, and then we're going to add 2 right there. We're going to add 2 because now it's 2 times 1. 2 times 1, so we have 6H2. I hope you followed that reaction. So we have 6H2, and then there's an O here, 6H2, 6H, you can see 6H, and then we have this 2 times H is H2, and then we have O, so O is right there, we have O, so O is right there. So you can see how we do the math, so now that's how it's reacting right there, that is how it is reacting right there, okay? That's how we do the math, and that's how it is reacting right there. So assuming we've been given 6,3, and then we have also been given H8, okay? 6,3H8 plus oxygen, 6,3H8 plus oxygen. So now we want to see how this chemical reacts. So for this chemical to react, we're going to have, you can see we have C and 3, so we have 3 right here. So now these three gonna come first, and then we put the C, right there, But now this C, we're going to add now. We have to add this C with oxygen. So now we have 3 carbon dioxide. Now we have 3 carbon dioxide. Now we have 3 carbon dioxide plus 4 because now we have to find out how plus 4 now, because hydrogen seems to have 4 atoms in it, or hydrogen seems to have the number of 4. So we're going to say plus 4, and then plus 4, and then water. So now water now. So now H2, H plus O2 is water. So now we have 4, and then HO. We have 4 and then H2O. We have 4 and then H2O. So you can see now when you do 4H2O, we're gonna have 8. So now we've taken care of the 8. So now we've taken care of the 8, because now you can see when we multiply 2 by 4, we get 8. When we multiply 2 by 4, we get that number 8 right there. So we get hydrogen 8 right there. So we get hydrogen 8 right there. So now we have to add heat to set the combustion going. So now the next element is heat. So now this kind of reaction, we're going to need heat. For this kind of reaction, we're going to need heat for it to take place. For this kind of reaction, we're going to need heat for this for it to take place. So 3 carbon 3 hydrogen 8 plus oxygen is going to give us 3 carbon dioxide plus 4 hydrogen oxide plus heat. So it's going to give us 3 carbon dioxide plus 4 hydrogen oxide plus heat right here at Paulstutorialservices.com, where we make learning fun and enjoyable. Right here at Paulstutorialservices.com, where we make learning fun and enjoyable. Please continue to share. Please continue to share this tutorial with your friends. Please continue to share this tutorial with your friends. So now when you look at for the first reaction, you can see what we did. We find that for the first reaction, you can find that we have for the element C, which is carbon, for the element C, which is carbon, we have at least 2 C's. We have two numbers. We have 2 numbers. So and then we have and then now, so we have 2, and then now so that would be the way we did it. So now we had, like, when we do then the side math right here. So we had 2 by 2, which gave us 4. So we have 2 by we have for carbon alone we had 2 by 2, which gave us 4. So for carbon alone we had 2 by 2, which gave us 4. And then for hydrogen we had 6. And then remember, hydrogen mixes with oxygen. Hydrogen mixes with oxygen to give us water. Hydrogen mixes with oxygen to give us water. So we had so now for carbon we had that, and then for hydrogen we had 6 by 2 to give us 12. For hydrogen we had 6 by 2 to give us 12. So now, so the rest was 0. The rest was 0. So we need that 0. That 0 is still important, because that 0 produces oxygen. When it mixes with that small 2, it gives us oxygen. So that 0 is not just 0. It is important. So you can see how we are having fun with this. You can see how we are having fun with this. And that's the meaning of Paulstutorialservices.com. That's the meaning of Paulstutorialservices.com, where we make learning fun and enjoyable. Where we make learning fun and enjoyable. Please continue to share this tutorial with your friends. Please continue to share this tutorial with your friends. So now let us look at the other side of the combustion. So far we look at this side. So for the other side of the combustion, you can see that we had 4 carbon. We had 4 carbon. So you can see we had 4. So now we had 4 right there. So C, we had 4. For C, we had 4. And then now for hydrogen also, you can see how we balanced it. So for hydrogen, we had 6 by 2, okay? For hydrogen, we had 6 by 2, which gave us 12. So for hydrogen, we had 6 by 2, which gave us 12. So for hydrogen, we had 6. We had this 6 by 2, which gave us 12. We had that 6 by 2, which gave us 12. And then now, for oxygen, now you can see 0 of oxygen. I call it 0, but it's not 0. It is actually an O. So that for oxygen now, for oxygen, you can see for oxygen we had that 2. Okay. For oxygen now, we had this 2 by 4 right here. So we had this 2. But now, because now this 4 carbon dioxide, so we had this 2 by 4. So we had, we can just say 4 by 2. For oxygen, we had 4 by 2 for oxygen, and then we added 4 now. So we had this 2 by we had this 2 by 4, right? We had 4 by 2 or 2 by 4. We had 4 by 2 or 2 by 4, and then we added 6, and then we added this 6 right here. So we added this 6 right here. So this now gave us a total of 14. So this now gave us a total of 14. So you can see the total number of elements involved. The total number of elements involved in this kind of metabolism reaction, in that kind of reaction produces. So you can see the total of elements involved. On the right side, we had 4 plus 12. On the right side, we had 4 plus 12. And then on the other side, we had 8 plus 6, which gave us 16. And 8 plus 6. We had 8 plus 6, which gave us 14. But on the right side, we had 4 by 12. I mean, on the right side, we had 6 by 2, which gave us 12. Yes, we are correct. 6 by 2, which gave us 12. 6 by 2, which gave us 12. Right here at Paulstutorialservices.com. Please continue to share this tutorial. Please click the follow button. If you are a new visitor on the page, please click the follow button and stick with us for more of these tutorials going forward. Please click the follow button and stick with us for more of these tutorials going forward right here at Paulstutorialservices.com, Paulstutorialservices.com Facebook page. So now let us see one more reaction, and this one. So this one is going to involve photosynthesis. So we are going to see reaction on photosynthesis. So we are going to see reaction reaction on, you're going to see reaction on photosynthesis. We are going to see reaction on photosynthesis right here at Paulstutorialservices.com. So now what we have is carbon plus hydrogen oxide. So now we have carbon plus hydrogen oxide, or if you like, water. Carbon plus that is carbon plus water, not hydrogen oxide. This is what we have here is carbon plus water, which is H2O. Carbon plus water, which is H2O, and now we are going to see how it reacts. And now we are going to see how that reacts. We are going to see how that reacts. So now for that to react, you can see we have carbon, and we have carbon and now that carbon carries up to 6. That carbon. So you see now, carbon itself has an element of 3. Carbon itself has an atomic mass of 3. So now carbon itself has an atomic mass of 3. So now it is not written there, but that's what it is. It has an atomic mass of 3. So we're going to say 2 times 3. 2 times 3 will give us 6. So we're going to say 6C. And then we're going to add oxygen. 6C oxygen. So we're going to add 6C oxygen. Trying to make my 2 looks good, so that looks good. Trying to make my 2 looks good, so that it is not interrupted with. So we are just going to say we are just going to say, even before we add the oxygen, we are just going to say carbon has an element of 3, and now this oxygen has 2. So we are just going to say 2 by 3 is 6. So we are going to have 6C right here, and then we are going to add hydrogen. So when we add hydrogen, then we are going to have 2, because this, when we add hydrogen, you can see this hydrogen has 2. This hydrogen has an element of 2, and now we're just going to multiply the 2 by 6. So now we are going to say H12. So now we are going to say H12 because 2 by 6 is 12. So we're going to say H12. And then now what we are going to do next is we are going to look at oxygen. We are going to look at oxygen. And now we can see oxygen as 2. We can see oxygen as 2. We already dealt with this 2 right here. We multiply this 2 by 6 to get H12. So now we have this O to deal with. Now we have this O to deal with. So we're going to add that O right here. We are going to add that O right here. And then now what remains now, because we've already added the O right there, so what remains is 2. What remains is 2. So now, O plus 2 is 2. 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 So now this reaction here, the product of that reaction, the product of this reaction right there, the product of this reaction right there, up to this point alone, as the product is called glucose. Up to that point alone, which is carbon 6 plus, up to that point alone, carbon 6, H12, and then looks like carbon 6, H12, carbon 6, H12 has given us glucose, but now there's something missing in there. There's something missing in there. So, but up to that point we have glucose. So now we still have to deal with this 6. I don't know if you noticed. So now this is this one gave us H12. So now we have to deal with 6 now. Okay, we have to deal with 6, H12, 6. So now this 6 here stands alone. This 6 here stands alone because 6 plus O. This 6 here stands alone. So now we have 6. So now we have O6. So 6 there stands alone. So now we have O6. 6 there. 6 is standing alone. So now we have O6 in between here. O6 in between here. And then plus oxygen. So we have O6 because this 6 is standing alone. So it's O6 plus oxygen. O6 plus oxygen. That 6 was standing alone and we cannot afford to ignore the 6. So we add it to O and now we get the reaction which is O6 and then plus oxygen. Oxygen is easy to see. We have oxygen, so we cannot ignore our oxygen. We put it there. We cannot ignore our oxygen, so we put it there. So now this reaction, carbon dioxide plus H2O, give us 6C plus H12 plus O6, which is oxygen, which is glucose. But then now you cannot have glucose alone. So now we also have oxygen. Oxygen is always there. Oxygen is always there in this kind of reaction for food to be processed. This is, remember, this is reaction on photosynthesis. That is a reaction on photosynthesis. That is reaction on photosynthesis. So now that we've seen the reaction on photosynthesis, let us look at the reaction on metabolism. So now let us look at metabolism reaction. Now that we've seen the reaction on photosynthesis, let us look at metabolism reaction. Now that we've seen the reaction on photosynthesis, let us look at metabolism reaction. Let us look at metabolism reaction. So now for metabolism reaction, we have we have C6, which is carbon 6. Then we have H2O somewhere. So we have H2O somewhere, not 2O, but H12. Yeah, it's almost the same to what we have there, but it's a bit different. So now what we have is C6 plus, we have C6 plus H12, then we have O6, you see, it's almost similar. Then we have O6, and then after O6, and then we have 6O2, then we have 6O2. have 6 O2. So now, what kind of reaction are we getting? What kind of reaction are we getting? So when we look at it, we already have we have 6 carbon dioxide. We have 6 carbon dioxide here, and you can see we have this 6. We have 6 right here, 6 carbon. We have 6 carbon. So how are we going to write it? We write the number. We write the number 6 first. We write the number 6 first. So because we have 6 carbon, so now we have 6 carbon. So we write the number 6 first. We write the number 6 first, and then we add carbon, which is C. So we add carbon, which is this C right here, and then after that we add our oxygen. After that we add our oxygen. So now we have this. Remember, when you do this kind of reaction, you start from your far left and you add to your far right. So now, also what we are doing is we almost close to doing the like terms together. You can see this C6, there's a 6 here, there's a 6 there. So now we add this one. We add oxygen right here. So we have 6 carbon dioxide in that kind of reaction. And then we still have another 6 to deal with. We still have another 6 to deal with. So clearly we are taking care of our like terms. It's similar to maths. So now we have our 6. So now we have our 6, and then HO2 somewhere. 6. We have 6, and then HO2 actually. Yeah, H, not O2, but we have 6, and then H and water. H and water. So yeah, 6. We have 6, and then so we have this 6 right here. We have this 6 right here, and then we have H. Then we have to put we have H, right? We have H, and then we have to put 2 before O right here. So we put 2 to mean water. So we have H2O. Remember, we are balancing this in real time. We are balancing this together in real time. So now we have 6 carbon dioxide. We have 6 carbon dioxide plus 6 hydrogen oxide, plus 6 hydrogen oxide, and then so now what remains is water. What remains is not water but heat. What remains is heat. What remains is heat for this kind of combustion to take place, for this kind of metabolism combustion to take place. So this is how metabolism takes place in our bodies. This is how metabolism takes place in our bodies. This is how chemicals bounce up. This is how chemicals bounce up in our bodies. So now this is C6H12 plus O6 plus 6O2. Okay. So it's carbon 6 plus hydrogen 12 plus oxygen 6 plus 6O2. So now you can see how we balanced it. We had to take care of this 6. So we did 6 times C. 6 times C. You can see 6 times C. We gave us 6C right here. And then now we had to add this oxygen right here. We had to add this oxygen right there. And then we came back over here and looked at this 12, H12. Now, H12, we had to balance it. remember, it's like solving an equation. So now, when we balanced it, we look at a number which if you multiply by another number, or by 6, will give us 12. So that number was 2. So we took 2 by 6 to give us this 12 right here. So 2 by 6 is H12 right here. 2 by 6 is H12 right there. And then we take care of this O. We take care of that O to get oxygen. And then now you can see it is balanced. It is balanced because now we ended here. Right here we have 6. We have 3 6s. We have 3 6s. But you see now, when you multiply this 6 by 0, it is 0. So now you can see it is missing on the other side. So we end up with 2 6 on the right. We end up with 2 6 on the right, because remember, we are balancing the equation. We are balancing the metabolism equation right here, and we multiply 6 by 0, and now 1 6 is gone. 1 6 is gone. 6 by 0 is 0. Therefore, the other 6 is gone. Metabolism right here at Paulstutorialservices.com. Metabolism reaction right here at Paulstutorialservices.com, where we make learning fun and enjoyable. That is Science Odyssey class for today, Thursday the 14th, 2025. That is Science Odyssey class for today, Thursday 14th, 2025. I hope you had fun. I hope you enjoyed the session, the tutorial today. Thank you for watching. Please help us share. Thank you for watching. Please help us share. Bye-bye.